Hi, my name is Michael Wolf, and I'd like to introduce you to my senior design project, the Inventory Management System for the Cal Poly Electronics Laboratory. Here's a brief overview of what I'll be covering. First, we'll go over the current state of the lab, then we'll look at some of the apparent issues with it. Next, we'll look to see what goals we can set in order to fix those problems. Then we'll look into some possible solutions and identify the most rational one. Lastly, we'll review the benefits that the new designs might include. Let's get started. This is the electronics lab for the Industrial and Manufacturing Engineering Department at Cal Poly. This lab helps students get on-hand experience in the area of electronics manufacturing. This ranges from soldering simple components as earlier students to the more advanced topics such as using pick-and-place machines and refill ovens. There is also a set of cubbies and boxes designated for reels of specific electronic components, including resistors, capacitors, and microprocessors. Those cubbies can be seen on the right side of the right picture. These machines and components are used to supplement electronics-related courses such as IME 156, Basic Electronics Manufacturing, and IME 458, Microelectronics Packaging. These types of classes are taught by various faculty members, including Professor Rob Carter, Tally Freed, and Jean Belpin. Because this is treated as a fabrication facility, or fab for short, it's important to keep the area clean and organized. There's a decent amount of foot traffic and use of the equipment throughout the year, so there's a very apparent need for strict procedures and rules as well. Currently, eye protection is to be used at all times. Soldering irons and other tools have designated safe areas and safety equipment, and most activities in the lab require supervision by a faculty member or approved student. The components in the lab are housed in reels as shown above, so that they can be used by the pick-and-place machines. They are usually housed on spools or in boxes, but are sometimes too small and must be kept in drawers. As you can see, the lab is still lacking control of its inventory, because a lot of these boxes and drawers are already disorganized or missing. In the near future, the department predicts the lab will be in heavy use, but there is no system in place to properly monitor the movement of component reels. The labeling design is also outdated, which makes the components and drawers nearly impossible to differentiate. These in combination force the faculty to search through the bins to find the appropriate components, which can take copious amounts of time in some cases. To make the electronics lab more efficient, it is essential that a new ergonomic labeling system be implemented. One such that newer students can easily identify and differentiate between many of the types of components. This system also needs to be reorganized so that specific components are easily identified and retrieved. Separately, an inventory system and database must be constructed and customized to keep track of inventory within the lab. The database and interface should be easy to operate and provide the ability to add or delete products as new ones are ordered. Additionally, an electronic database that has compatibility and functionality with an automated identification device would provide the most utility to the user. The first and most simple aspect of the project is designing a labeling system for the lab. This system uses concepts from electronic circuits and ergonomics coursework to simplify component specifications and make the lab easier to understand and operate. We will use a standard label with the following layout. The first section specifying product specifications, such as the component type and value. A resistor, for example, would have a value in ohms, kiloohms, or megaohms. The next parameter will define the size of the component, detailing the width and the length. The last area of the label will include a manufacturer ID number or name that will be specified later on in the project. More areas of the label can be added later on in the project if needed. Here are a few potential designs that could solve the problems with the lab. These are just a few of the options that I believe to be within the realm of possibilities for the project. A card-style Kanban system could be used to cheaply identify lower levels of inventory, but would also allow no such connection to a database, unfortunately. AIDC, as I mentioned before, is an extremely efficient technology that would produce a very viable solution to the lab's problems. These types of systems, such as barcode scanners and RFID, are extremely efficient and accurate models for capturing data. Barcode uses static types of data and requires short distances to read, but are very accurate and cheap. RFID, on the other hand, is a more expensive technology that is primarily used to monitor inventory in large-scale fabrication facilities. It offers dynamic datasets, accuracy for mobile inventory, and can cover either short or long distances depending on the specific application. Because one of the main objectives involves electronic data and its manipulation, we will be primarily focusing on AIDC technologies. The database we're using primarily needs to be designed to simply integrate with the inventory system. A local database, generally a file from Microsoft Access or Excel, would provide a high level of utility for the given system. It can provide dynamic databases that are compatible to upscale with larger programs. A network database would also provide a very high level of utility and complexity, but can be tricky to implement and requires routine maintenance. A cloud-level database, the most current of database technologies, is a very useful method for managing large datasets, but is very expensive. For this to be feasible, it would require a scope much larger than that of this project. The technologies that most accurately accomplish the objectives of this system are essentially encompassed by AIDC. However, due to the size of the lab and the scale of the project, RFID technology seems to be a bit unfitting. Barcode technology uses parallel lines and spacing to represent data, which can be read by a scanner and transmitted to a computer relatively easily. This method is the most applicable technology to this project, primarily because it is cheap, accurate, and can be integrated with computers seamlessly. We are limited to a small range of space in the lab, so even the limited range of barcode technology does not add any difficulties to this project. The database for the electronics lab does not need to be particularly complex, but does need to be easily updated, customizable, and compatible with barcode technology. The tool that most effectively accomplishes these goals is a local database designed in Microsoft Excel. We can apply skills from computer programming and database management coursework at Cal Poly to properly create and implement an inventory file with macros and interfaces so we can easily input data. Microsoft Excel is an extremely versatile program, and due to its familiarity, can be operated and maintained somewhat easily. The combination of the database, labeling method, and barcode data capture will solve all the problems identified by this project, and may even provide support for further expansion of inventory management at the lab. The labeling system and organization method will allow the faculty members and student assistants to easily differentiate between various component reels. The database will eliminate the need for inventory checks and keep the faculty more informed about the available components in the lab. Lastly, the organization of the lab will remove clutter from the shelves and promote a more cleanly and lean system within the lab. This also provides the basis for future additions to the inventory system, such as tools and other large components used in IME 156. And that concludes our presentation. Thank you for watching.